name's Andy. I'm from a company called Zagami, and we've produced this tool that's used by a lot of different kinds of biologists and various people doing applied image processing. And what I really want to talk about today is the way that we got people using it, and the specific people we really needed to get using it or installing it first and then installing it on their systems were kind of university systems administrators, these kind of guys. So often with a data science product, you're really trying to actually make an impact in the world, get it out to this kind of people. So what did we have to do? Well, the main thing was to make it easy to install. So carry on like that. So the tool that we used to make it easy to install was Conda Constructor. So Conda Constructor is an open source product produced by Continuum that goes alongside all of the rest of the Conda build environment. And yeah, as I said before, we've got, typically you may be thinking about producing software that's about data scientists, informaticians, but actually, yeah, there's this whole group of other people in universities that have fewer technical skills. And then we've heard talks about Jupyter dashboards, etc., that are ways of getting your software out to them. So, and recently we got some feedback. It was the best installer someone had ever used, and he was so surprised because it was using Python and that it was actually easy to install on his Windows laptop. It also, yeah. So the GitHub URL's here, and it's just to bundle up a one-step installer or a graphical installer for Windows for your Conda projects. So the sort of things you can set up on it are start menu items, desktop icons, custom scripting before and after you install, a license agreement, and it should work for any Conda package. So the sort of packages we used fell into a few types. We had this Zagami dependencies package, which was just all our dependencies, so that we could avoid duplicating the dependencies between the constructor files and the rest of our development pipeline. We then had our own forks of various pip packages. We had some custom Conda packages. So I'll show you on the next slide, but we actually packaged in things like .NET Framework, which we used to wrap a Windows service around our tool. We had our own kind of compiled encrypted source code, and we had even was possible to package in other programming languages like Java, all under Conda. So you start off with a construct.yaml file. You've got a number, it's very similar to a normal Conda package. You've got your channels, your version for the actual whole installer. You've got a number of sort of dependencies, and then you've got how long have you got? 1 minute. Okay. Then you've got images that come up in the graphical installer. You go into the directory with your construct.yaml, and you run constructor dot. We did a few crazy hacks with it. We made it build under Linux. Ask me about it if you're interested. And then, so thanks to everyone for listening. Thanks to Tarek for being a great mentor for me. And anyone's interested, anyone wants to come and work for us, get in touch. Cheers.
Thank you, Andy.
Hello. Okay. So my topic is going to be data for evil. And that's sort of inspired by our earlier keynote speech, which was data for good. But I put a question mark because You'll find out soon enough. And I'm a master student at King's, and I'm gonna work for Infosys at India this summer. So my personal, I guess, involvement is in Python and data, less so in science and magic, because it's quite difficult to understand sometimes. So I think this quote is quite endearing for me, because it's one of the professors that told me, you have no control over who uses your data and for what purpose in the future. And she was talking basically about how her research had been utilized for war in a good way, which I'm going to explain now. So the topic, my background is Libya, not Libera. So it's going to be on the right side, that side. So why Libya? Because of cultural artifacts there. Phoenicians, Carthaginians, Greeks, Romans, Arabs, Ottomans, they all went through Libya. It's quite interesting. Now it's in civil war, so many of it is being destroyed, sadly. But there's a lot of, 5 UNESCO heritage sites alone, and yes, that's being under destruction right now, sadly. And it's why I use this case. It's because it's the only case I can think of where it was being used for good. Otherwise, I think it's all being used for bad, like target acquisition and drone strikes and whatnot. So, sad thing. So this is just an example of what there is. Greek. I think these are Roman. I think. I'm not a classic student, so I would not know for sure. So that's the history. That's the current, 2011 civil war. Gaddafi overthrown, NATO no-fly zone. That's sort of the nutshell, I suppose. And in the process, NATO wanted to find out what they were gonna strike, and who they were gonna strike. And so the good thing was these people approached the professors involved in this research, where they had pinpointed locations of Greek, Roman artifacts and heritage. So you can search it here on the bottom link. And basically these people came over and said, hey, we're gonna be creating a hit list, and we're gonna give it to NATO, and we're gonna give it to MOD, Ministry of Defense, on the British side. And they said, okay, sure, and then they gave them the data. Of course, there's always the bad things that happen. So data collected by the professors, which was used in an academic context, was used in something that they never intended, which is quite sad. But I suppose that's how data is used. Sadly, the heritage sites that were not destroyed by NATO were destroyed later by the militia, art dealers who are always there, and like people like ISIS, I guess. So A for effort, at least they tried. The civil war is ongoing, sadly, and if there's any left, it's still in danger, according to UNESCO. So other use cases for data in war, usually it's these 3 things or more: simulation and modeling. There was agent-based modeling earlier, so that's quite similar. Supply chain logistics, I worked on the logistics, so aerospace logistics, and a lot of it is to do with predicting when's the next malfunction, et cetera, et cetera. And then, of course, the most typical, who should I kill? So the takeaway is data collected today might not be used the way you intended. And I think it applies to everyone here. And so leave behind good quality data, not because, you can't predict who's going to use it anyway, but at least let's hope that it will be used for good. It's sort of an optimism right there. And then data in defense is really questionable, sadly. And of course, war is evil. So thank you for our sponsors, and thank you, PyData. Thank you.
Thank you, Juan.
So you may recognize me from yesterday's lightning talks. I seem to want the attention. But I'm not going to replace Emlyn with a tweet bot today. He's suffered enough by being beaten by a dead man in the best tweet competition. So one of the hats I actually wear is I'm a volunteer for DataKind, and you all heard wonderfully about it this morning. They didn't use any of this project, so I thought I'd throw this out there because this was some kind of cool results we did. Me, if you didn't pay attention yesterday, that's me. DataKind, the great thing is, because you've already had a keynote, I don't have to explain who they are. They do great works. You're all brilliant people who can do great things with data, and you should all volunteer. And this is why. The project that we did, the dive, we did back in November. The UK has actually done something quite groundbreaking. They have required all companies to release the ultimate beneficial ownership of them. You cannot just now, in your annual filing report, you are owned by company B. You have to find out who owns company B, and there has to be a human person at the end of that chain if there is an individual who has significant control. So we wanted to take the early release of the data and see if we could find interesting things in there that might map to fraud or tax avoidance or things that aren't good for society. So ripping off Marvel, this is kind of the idea and the concept of one of the teams that I was working with, that we've got companies that are controlled by people like evil Green Goblin, but they may be connected down to media companies that you don't think are evil, but you want to actually figure out what's going on. Are they registered in the Cayman Islands versus registered in the US, that sort of thing. Of course, this is all really difficult because actually it turns out Companies House, despite claiming they have very clean data, don't. Where your nationality is a free text box, so people declare themselves as Cornish or British with 2 T's. So I wanted to give a special shout out to these two guys. They tried to deduplicate our data when trying to figure out if one person was actually the same person for a load of this. It's beyond the scope of this lightning talk, but go and have a look at their GitHub. I'll put a link out to this after the lightning talks. But what we actually did was we took like 65,000 companies and an equivalent number of people. You can kind of see the numbers of companies, the number of people, the number of locations, and we built up this massive graph network. Which is great. It's fairly simple, basic sets of relationships. But here's the cool thing. We did this in Neo4j. We did it in the community edition, which is nice and free and easy to use. And it instantly allows you to visualize the results of your queries. So in a hackathon-style environment, it was really good to get going. So the sorts of things you can suddenly find are these huge, large corporate structures. No one person does control this. This is Reckitt Benexa. So you can find all the way down to Lloyd's pharmacies are hidden away in there, all the way up to the master pharmaceutical company. At the other end, this was kind of one of the key things, was trying to find tax havens. So suddenly you see this company, this person is registered actually in the Cayman Islands, and it's a company. That company's registered there, it controls that company, which is controlled by this person who actually is resident in the UK and a citizen of Germany. Are they paying their taxes appropriately? Is that the sort of thing that you can suddenly easily get out? What else did we find? Also, we found that there is a 20-year-old woman in London who owns 758 companies. Each one has got one share worth £1. So it's actually probably not dodgy. It's something called a company factory, we were informed. We didn't know about this. But you can start finding all of these really kind of cool, interesting networks, and maybe there's something that needs to be done. And ultimately, what was the impact we had? Well, you take data, you take a load of volunteer data scientists, you plug them into a data dive, give them a load of coffee, pizza, and beer, and 20 hours later, we had results that actually the UK government has agreed to adjust some of the data and fix some of the problems. Companies House is addressing some of their free text fields, hopefully. We developed a number of leads which were going into some investigative journalism pieces, which hopefully will appear in The Guardian. And we even got called out by the government in France at an anti-corruption summit saying we were an example of best practice, such that Nigeria and Belgium then contacted DataKind UK saying, how do we do that? And some other stuff, details. There is, I will, however, say, a number of blog posts, including one of my own at horsewiththepointyhat.com. Feel free to go and have a look. If you've got any questions, you can grab me if you can see me. And if not, you'll see me at PyData.
Thanks. So this was going to be my only slide, and then I felt embarrassed, so I made some more. So I had the idea of just plotting the Wi-Fi data that my laptop collected over the weekend. So so this is upload speed, this is download speed, and the size of the dots is the ping time. So bigger is bad. And then I thought, well, so So note the scale on this, because I didn't keep the scales constant from plot to plot, in part because it becomes unreadable. I had this idea then that maybe I should show a couple other Wi-Fi networks. So this is my home network back when I had 500 megabit fiber. And it goes up to 100 there, you can see. And then we got gigabit fiber, and it looks like that. I have somewhat more data because there was a bug, and I was forgetting to note the name of the network. So I have lots of data where I don't know what network it was. This is interesting because I use speed tests to gather the data, and I'm pretty sure that speed tests just can't find a counterparty that can measure a gigabit connection. By the way, do you guys know speed tests business model? They sell data. They've gamified finding out what your network connection details are, and then they sell the data to internet companies to find out, so that they can find out what their network actually looks like from the consumer side. So, this is the set of all Wi-Fi data I've collected over time, where I actually have a network name. Now, I'm going to set this down for just a sec. So then I felt bad, and I just made the same plots with color maps. So now the light things are, I think, are the older ones, and the dark ones are newer. And I suck at making color maps, so so it's almost black and white instead of grayscale. But here's the same one again with my home network, and here's the same one again with my gigabit home network, and here's the same one with sort of everything I've ever seen. This is a lightning talk. You want to ask questions? Well, so for example, here's bguest, right? So what this tells us is that we get quite a bit of variety in terms of what connectivity we get. That on the plus end, we're getting about 60 megabit per second upload and 70 download. And at the bottom end, we're getting something like 10. And it tells us that it's roughly, there's relatively good correlation between the two of them compared to, say, this, right, where the correlation isn't as good. So it's just sort of a, I mean, practically, it tells us there's a lot of variation. Beyond that, I'm not sure it provides anything useful. I don't know a way. No, I mean, you know, we learn what we can from the data, and then that leads us to ask other questions. One question that it made me ask, and I'd be really curious if someone can think of a way to do this, is to measure how long it takes to connect to a Wi-Fi network, because for the first time in my life, I was really curious what the distribution of that time was. So anyway, that's about Wi-Fi.
Now, one of the things you may have seen over the last few days is a little stupid piece of software that I wrote for creating slideshows. And I decided if it's a stupid piece of software, I'll name it after a stupid person. So I called it Emlyn 2. I've decided from now on that every piece of software I write will be named after somebody I know. And the reason for that is I don't really want other people to use this code. So the less documentation, the less explanation, and the more obscure the name, the less of a chance anyone will ever use this. That said, for those of you who were there at the pub quiz yesterday, you got to see a little bit of what this tool can do. Because in about 15 minutes of time, we took what was a fairly simple slideshow presentation and added some very sophisticated elements to it. If you were there at the pub quiz, you saw that this is our pub quiz, and you see there's some flashy text, and you can actually see we know how many questions are left. We're actually counting how much time there is left, so as we go through the questions, the time goes down. The estimated time to completion actually goes down. So you can see, are we on track to end? We ended at like 10:30, so we weren't. And you can see, and this was all like just Tom Cloyver was like, hey, can we add this, can we add this, can we add this? And we hacked it together. The code was terrible, but I love tools where you can just kind of hack something together and it works. Now, before I actually show you a little bit about the tool, I want to show you one or two of my favorite questions from the pub quiz, especially for those who missed it. So I would say this is about the hardest. People were complaining how hard it was. This is the hardest question on the pub quiz, probably. It's not that hard. But it wasn't my favorite question. That one was okay. My favorite question was, and this section is called Spot the Bug. my favorite question was, let's see where we can find it. Give me a second. Just pull it up. The gimmicky text actually ended up being a little bit how that's helpful. It's right in here. So this is my favorite. This was my favorite question. Spot the bug. Those 2 lines. This here. This is a tab. This is spaces. It's inconsistent indentation error. So that was my favorite one. Oh, you can see that they display link when you run out of time, so we could keep on track. The other really cool section that I thought about the pub quiz was this question here, which was, it was called "The Names are Changed to Protect the Innocent." Can you guess, this one here, can you guess what library we're using and what the Who Am I is? And so we had to guess some things about common libraries we use every day. So for those of you who missed the pub quiz, you really missed out. Now, let me tell you a little bit about the tool, Emlyn 2. By the way, Emlyn 1 is not this guy over here. He's Emlyn 3. Emlyn 1 was my first variant of this tool, which ended up being kind of crappy. The idea was I wanted to be able to write slides really quickly. If I give a 1-hour talk, I want to spend 1 hour writing the slides. So can I just have, there's a tool called Scent from a group called Suckless, and they basically had a slideshow tool like this written in 1,000 lines of C. I hacked on it a bit. It didn't do what I wanted, so I decided to rewrite it in Python. So I ended up starting to add like directives, and you could do weird stuff, like you could put Python code embedded in it, and it got messier, 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 messier. And so on the flight to PyData Amsterdam, I had 6 hours, so I decided, let me just rewrite it from scratch, because that's what you do on a flight to a Python conference, I guess. Surprisingly, when I try to explain this to my friends and family who are normal people, they have no idea what's going on, and they actually often specifically tell me that they regret asking me what that is. But for you, I guess this is totally normal. So I rewrote this as Emlyn 2, and it ended up being much simpler, the idea being that, if you think about it, a slide is just a generator that yields the text that's going to show up on the screen. Once you have a generator, you can do pretty much anything inside that generator. It's just a function, just a coroutine. So you could, for example, pull data from a Google Doc. You can do all sorts of things. And that's how basically every effect is generated on Emlyn 2. It's just a generator you write yourself. And so this is the actual, this is the questions for the pub quiz. We were able to put them together very quickly because each question is just the text that shows up, and we were able to put little tags on here and to do things like pulse the text and whatnot. All of that was just a Python script. The thought is that I like writing Python scripts. I don't like writing slideshows, so instead of writing slideshows, I'll just write everything as a Python script. And so the pub quiz itself is a 163-line Python script that encodes all the behavior that it has, plus a text file that just loads slides from it. Very simple. So this code will probably be put on, it's already on GitHub, but it'll probably be updated on GitHub when I get back, because there's a couple of things I need to do better. I really don't want anyone to use it, except I keep trying to convince Thomas Cloyver to use it, just as a point of pride. Outside of that, I don't know how useful of a tool it actually is, but it can do some gimmicky things like show up these slides, and you know, it's a way to create slideshows really, really quickly. There is one core message that I take away from this, because whenever I do corporate training, I always tell people Python is a system itself. It has an enormous amount of functionality. When you're writing million-line frameworks on top, you're doing it wrong, and that's exactly the progress that I went through with Emlyn 2. The very first version was a humongous framework with all sorts of modalities. The second version was, well, it's just a Python generator. And the third version was, well, it's just a really simple Python generator. And so the last version of this tool, the one that hopefully none of you will ever use, oh wait, no, none of you use it anyway, so whatever. But the last version of this tool will actually heed this idea. Python is a very complex system as a language. It has an enormous amount of moving parts and mechanisms, and you can actually build very complex tools without writing lots of code, without writing huge frameworks, by just sticking to what does Python do, by figuring out a generator as a slide. So we'll keep it like that. Thank you.
Thank you, James.
Hi. So what I wanted to do today is to defy the gods of the live demonstration by proving, during the course of a lightning talk, how easy it is to get the Jupyter Notebook running on a Linux system. I have no idea how difficult it is to get running on a Windows system, because I've not used Windows for quite a while. But basically, what I want to tell you is I've got nothing up my sleeve, so you will notice that at the beginning of the script that I'm going to run, I set the path, which only includes user local bin, so I can do a wget of the download file. The rest is stuff that you'd expect to see on more or less any shell. So what I did was I went and I found the URL of the macOS 64-bit bash installer, and it's very simple. Basically, once you've got that URL, You just download the installer, which is a shell script. You execute the installer. You've then got conda. You can create an environment, because of course you never do anything in your root environment in Python. You create a new virtual environment, you install Jupyter in it, and you run the notebook server. So hopefully we'll be able to get all that done before the end of the lightning talk. So this is what it looks like as a script. Basically, I set the path. I then do a wget of the file. I then run that file, and you've specifically got to use the bash shell there, so that's very important. Once you've done that, basically you've installed Python, so you have to, installed conda, so you have to make sure that the newly installed system is on the path. The one thing I have to do is, because I'm running the installer interactively, I have to make sure that my user input does actually end up, thank you, no, it's all right, we'll be good. Does actually end up putting the conda installation where I want it. I then create a new virtual environment, conda environment called demo. I activate that, I install Jupyter into it, and I run the Jupyter notebook. So that is the plan. So you'll see that I have here in another window, I've got this shell script ready to go. This is just to prove that I haven't tweaked the script at all. It's the exact stuff that you saw on that slide. So now, because this is not intended to be a permanent installation, I'm going to do it in temp, and then I'm going to time running that command. So here we are, we're downloading the installer file. That's come down in 3 seconds. Now I've got to say, yes, okay, here's the license. I'll use Q to indicate I have actually fully read it and understood it. I now make sure that I use, and the reason why I'm using a script is anyone who's seen me type knows it'll take you a week if I had to do the typing. Okay, so now comes the awkward, anxious waiting bit. What's going on in there? Oh, good, installing Python 3.6, that looks good. Various other packages going down as well. Lovely, creating the default environment. Do you wish the installer to prepend the install location? No, I won't bother doing that, thank you. But it very kindly does tell me what I should do. So while it's fetching the metadata for Jupyter, you can just copy that. It's already in the script, so I don't need to do so. Let's now proceed. And you can see that it's installing all kinds of stuff that Jupyter needs. Isn't it tense? Oh, there we go. Jolly good. So now I'm actually installing the Jupyter stuff, all the dependencies, widgets, extension, blah, blah, blah. Proceeds, and now it downloads all these files. This is actually probably the longest part of the process, particularly that one Qt file seems to be extremely big. The rest of them come down fairly quickly. It's now downloaded all the dependencies that puts Jupyter into the conda environment that I've created. And again, we have a little tense wait because nothing actually appears to be happening, but honestly it is. There is stuff going on in the background, I think. Good. Oh, wonderful day, thank you. Well, right until now, everything was going very well. Oh, there we go. And so now we have a Jupyter page. I can actually create a new Python 3 notebook. I can import sys, and I can print the version to show you that I have indeed got the very latest Python 3.6.1 from Continuum Analytics. And if I Control-C that server, that all happened in 2 minutes and 22 seconds. Thank you very much.
Okay, so most people here are using Python to do various things. I come from a C++ background, and occasionally I'd like Python to be able to call my C++ functions. And ideally, I'd like to do this without having to do any work at all. So this tool hosted on GitHub will help me do that. So because I'm not nervous enough, this is all going to be live coding. So yeah, we'll use Jupyter Notebook to get things working. So there's a bit of C++ over here. There's not a lot of it. It's not very complicated. It's defining an abstract shape class and then a circle which derives from it. It's got pi in, which everyone knows is 4. And we'll use Jupyter Notebook to spit that out to disk. So it's written our shape out for us. And then we can invoke Clang and compile it and see if it's valid C++. And that doesn't say anything. And if we make a mistake, call it override instead, then Clang will tell us that that was wrong. Very nice, all good, it is real. It will go properly wrong at some point. So, okay, so then we'll read in the code using libclang, which is a C API into the compiler internals. So that gets read in. We'll import the Python module for libclang, and we'll build a translation unit out of it. We'll build an AST out of the translation unit. So the AST is the abstract syntax tree. It's the compiler's understanding of what it's just seen in the code, and it looks like this. And we can parse it with some Python to get a tree representation of the code. So this, if you can't understand C++, this is even worse. If you can understand C++, this is still even worse. So we don't want to work with that. Like, yeah, okay, I can believe the compiler can understand that. So the first thing we'll do is build some simple Python classes to turn that AST into something we can read. So I have some code, and we'll consume the translation unit using that CPP model. And that gives you nice methods like functions and classes. So we can see we've swallowed up this AST and we've imported things from the standard library. So it's got methods called toString and operator S and all sorts on it. We can have a look at the class names, and we can see it's got shape and circle in there. And then we can have a look at the content of things which were called shape. And then we see, there we are. So you can see it's got the names. It's got the function names from shape. So that's good. Looks like we've got some input for stage 2, which is going to be code gen. So I'm using Ginger 2 templates to do this. That may be a regrettable decision. I'm not sure. If people know lots about Ginger 2 templates and can tell me what I'm doing wrong, I will listen to them at length, but it does work. So we'll feed those Ginger 2 templates. We'll feed the input we got from the AST, which has been consumed into Python classes, into these Ginger 2 templates, which will happily consume Python, and run my little code generator script. I'm telling it I want some C-based stuff. I want the JSON you can see on the screen, and I want also some Python because, well, it's a Python conference, so why not? So it'll run, and let's see what it's created. It's filled my disk with some nice things, and I can have a look at one of those. And we can see we've got JSON for shape, and it's got some methods in it. That all looks very good. And here it gets a little bit hairy. We'll write CMake list file out, and we'll compile it. So we'll write CMake list file, and hold your breath. Okay, so that's built. We'll have a look at the shared library it built. So it's built a shared library, which has got functions called things like shape circle create, shape circle area, which looks good. It's got a whole load of other load of debugging info, which we're not very interested in. We'll have a look at the Python bindings it's produced. So it's generated some Python bindings, and then we can go down to the bottom, and we can try running those. So we'll run Python 2. We'll run the shape class we just created. Python 3, PyPy, Intel's Python, and then, okay, if I put a negative radius into a shape, thank you. I put a negative radius into the shape, up you go up to the top, and C++ quite correctly says, if you put a negative radius into a shape, it's going to generate an exception and throw an exception. It's all very nice and talkative, so let's see what happens in Python if it happens. So this should probably bring the whole thing crashing down. No, it just gets translated into a Python exception, and that gets thrown across the API boundaries for us. Okay, so I said at the top pi was 4, so if anyone still doesn't believe that this is live, we can go and correct that. And then we'll run. And down to the bottom. And we'll see radius has changed, area has changed. So yes, circle radius 8 has in fact now got a slightly more accurate evaluation of the area. So yeah, this is an open source library. It's on GitHub. It's in a very, very early stages of development, and if anyone's interested, please grab me afterwards. Thanks.
Hi, I'm Pavlo. I spoke about Jupyter dashboards on Friday. So decided to do this lightning talk. It was pretty much inspired by the brilliant PySpark Cambridge talk earlier today. So I wanted to share a few things. First of all, AWS Lambda. Who uses AWS Lambda or AWS in general? AWS Lambda now offers Python 3.6. Because previously it was only a hacky version of 3.4. All right, so that's since. I know, but they offer 3.6, and that's a great. Also, PySpark is super easy. It's super easy to set up, even on Windows. I will show both in a second. So first I want to go through the slides so to make sure that nothing goes wrong during the live demo. And yeah, speak to me if you're interested in either of these aspects, like running AWS Lambda,
3.6, 3.4 notebooks, and Zeppelin as well. Right, so let's, no, that's Spark. Okay, so here's our AWS Lambda. I have a function that, you know, like in AWS Lambda, you have a callback. So if you want to execute something, you have to call it directly. So using, let's say, sub process. And that's what we're going to do, test. Okay, we just had an execution. And here, can you see in the box here, it says it's 3.6.1. Yes, obviously it's running on Linux. And I was like, so what do you guys give us as a 3.6? Because 3.4 version was really cut down version of Python. Now they give us pretty much the standard library. Look, you see the, I don't see modules like tab nanny, but that looks like pretty much all the standard libraries here, so that's good. Next topic is PySpark on Windows. Look, it's Windows. Right. So here I just earlier today, like after. I guess after 5 already, I set up a Spark on my machine. I ran some tasks. So that was the computation of Pi. Well, like Raspberry Pis and just Pi. So this is just a number Pi. Here's the notebook that actually uses PySpark. So what we have is we have a master node, and we have like workers, but it's only one worker at the moment. If you wanted to connect, you would be able to share your CPU time. Applications that I ran. So just to show you that it should run, start and run all. So basically, the way it works, this is true scalability. You can keep attaching workers to your master node, and you get parallel execution in Python. All right, okay, just to prove that we are running, refresh the page. Look, it's running, a new one. You see this guy? It's been running 10 seconds, so it will finish in about, yep, it's finished now. All right, so these are the main kind of bits of information that I wanted to share with you, and I hope you can make use of it. AWS Lambda, Python 3.6, PySpark is awesome, can be set up on Windows, easy. Get in touch with me if you want to know how, and I should probably write it up. And while we have some time, Zeppelin notebooks were mentioned. Yeah, I kind of used them in my previous life, and look, they're awesome. Like so, so the things that you can do with Zeppelin notebooks is these are kind of the languages, I suppose, or flavors that are available. Spark. Markdown, yes. Angular, nice. Shell, SQL, Elasticsearch, nice. And some things that I haven't used. And the plots, they're just brilliant. So once you visualize the data. Do we have an example of a SQL command here? Yes, we do. So that's just, look. Who doesn't love SQL? All right, well, thank you guys, and thank you. I want to thank the organizers of this conference. It's been brilliant, and see you guys around.